Here, we've got a beautiful example. We've got 345 miles of ocean and sky. Now, on one side, that represents 5 degrees of curvature. On the other, it's completely and utterly flat. Amazing, huh? Now, before 100 miles looking from this altitude, it's pretty hard to tell which is which. But much like when you go to a hardware store and decide, is that plank, is that skirting board, is that floorboard bent? You have to look down it on one side to see if it's curving. And we can quite clearly see that this is curving. That represents 5 degrees over 345 miles. Okay, awesome. So now let's look at what an observer would see at 1 meter at a line of ships going away. Now, on the top view here, we have a curved surface, which is this one on the left. And on the right, we've got beautiful flat Earth on a flat surface, which is this one here. The ships are identical distances. And in fact, if I show you the distances from the side and zoom in, we can quite clearly see that these are the same. There is a slight elevation difference, even at the 1 meter height, but we can still see all of the ship. And if we go to the next one, guess what? There's a slightly more difference between them. And if we go to, let's say, the last one, for example, we can see that now there's quite a difference between them, but they're both at the same level on their respective water surface. Okay, awesome. So let's get back over here and have a look at this. Now, on the top views, we have on the left the globe prediction. Now, a very interesting thing about these vessels is the observer is actually parallel to the red line of the hull, which is this red line here. Now, the laws of perspective and the parallel line formed with the eye height and the water surface dictate that this vessel going away, our eye line will never leave this red mark on a flat Earth. And indeed, on the flat Earth, we can see here, the red mark matches up with that red mark, which matches up with that red mark, which matches up with that red mark. So that kind of rings true. Except if it was going on a curving surface, we'd see something else. We'd see that vessel go downwards. And it would diverge away from that singular line that should stay parallel. And it would start going down and then down. And we could see how much of the vessel is hidden because I can outline it. We can see that water sits between us. So here, if the ocean is in fact curving on the left-hand side and the ocean is in fact not curving on the right-hand side, guess what? We can see a vessel 300 miles away if we had the optics to do so. And this would actually show up in a P1000 at maximum focal length. You'd be able to see this take up a number of pixels. You can work this out yourself. It's not magic. Now, one of these we don't see hardly at all. And when we do, it's a wavy mess. One of these we see predominantly, and it's the one on the left. So what I can say is if you curve the ocean at 1 degree per 69 miles and you put boats on it at distances that you see in reality, guess what? It matches reality. Whereas the flat Earth never does. Unless it's a wavy mess where ships are made out of jelly.